Okay, here are the solutions to version 2 of the test 1 review. Number 1, find the greatest common factor, or GCF, of 14 and 42. So what we do with that is we list all the factors of 14 and 42. So like 14 would be 1 times 14 or 2 times 7. These are all factors, 1, 14, 2, and 7. Then do the same thing for 42. 42, now that could be 1 times 42. Could be 2 times 21. We can check if it's divisible by 3 by dividing 42 by 3. Add up 4 and 2, you get 6, so it has to be divisible by 3. 42 divided by 3 is 14, so 3 times 14. And then finally, the one that everyone knows for 42 is 6 times 7. These are all factor pairs, okay? 1 times 42, 2 times 21, 3 times 14, 6 times 7. What we're looking for is the greatest common factor. And the greatest common factor between 14 and 42 is 14. Okay? So the way that you write that is, over here we'll write GCF, open parentheses, 14, comma, 42, close parentheses, equals 14. Okay? So just list out all the factors, all the different ways that you could possibly think of, and choose the biggest one that's in both sets. Okay, reduce, this is number 2, reduce 45 over 72. Okay, first we need the greatest common factor between 45 and 72. 9 times 5 is 45. 9 times 8 is 72. So 9, right? We're going to divide the top and the bottom by 9. So let me write my fraction out. 45 over 72. Divide the top and the bottom both by the greatest common factor. Okay, so this is the GCF. You're going to divide by the GCF. 45 divided by 9 is 5. 72 divided by 9 is 8. You end up with a reduced fraction. Okay, when you divide the top and the bottom by the greatest common factor, you'll always end up with a reduced fraction. If you don't end up with a reduced fraction, you didn't divide by the greatest common factor. Okay. And we're just going to repeat the process. 36 over 16. The fact that it's an improper fraction doesn't mean anything. So number 3, reduce 36 over 16. Well, 6 times 6 is 36. Here, I'm going to write it out correctly. So I'm going to take 36 and break it down. Got 1 times 36. 2 times 18. 3 times 12. 4 times 9. And 6 times 6. All of these factor pairs multiply to give me 36. So now we'll do the same thing for 16. 1 times 16. 2 times 8. That's it. Is there anything else? No. Oh, 4 times 4. All right. Good. So these are my factor pairs. for 16. So what I'm going to do is go find the biggest number that is in both sets, and it's actually just 4. Okay, so the GCF of 36 and 16 is 4. What that means is that I'm going to divide the numerator and the denominator by 4. Okay, I'm going to divide by the GCF. 36 divided by 4 is 9. 16 divided by 4 is 4. That's a reduced fraction, and it's the answer. Number 4, find the least common multiple, LCM, of 4 and 18. Okay, this is very similar to what we've been doing, but here's how we do it. And I saw some people doing this, so I was really happy to see that. Just write out 4 and write out 18, like this. We're going to start listing multiples. So we do 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 4 times 8 is 32. 4 times 9, 36. 4 times 10 is 40. Okay, so we're going to list all of the multiples of 18. When the numbers are big like this, it gets a little complicated to list the multiples. So we start with 1 times 18, that's 18. 18 times 2 is 36, and I stop because I find 36 here and here. I don't see 18 in this top list, so I have to go up 1 to 36. These are all multiples of 4, and these are multiples of 36. So if we're looking for the least common multiple, and by least common multiple, I mean the lowest number that is common in both lists, it's going to be 36 here and 36 here. So we can say LCM of 4 and 18 equals 36. These skills that we're learning here are practicing GCF, LCM, and now coming up LCD, greatest common factor, least common multiple, lowest common denominator. These are crucial skills for fractions, and that's where this problem comes in. This problem merely asks you to add 2/3 to 1 and 1/5 together, okay? That's all it's asking you to do. But in order to do that, you have to think of the lowest common denominator between 3 and 5. And the way that you do it on paper is you're going to write out all the multiples of 3 and 5. Okay? So it's kind of like, I'm going to write it out like this. 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3 equals 15. Okay? 1 times 5 equals 5. 2 times 5 equals 10. 3 times 5 equals 15. Stop. Because I see that my LCM, my least common multiple, is 15. And if we look at the component factors of 15 in both sets, it's 5 and 3 and 3 and 5, okay? Many of you are very familiar with this. This is just a little bit of review in how we come up with these. So what do? Well, I'm going to put an arrow here, because what we do is we multiply each fraction by a fraction that will make the bottom number be the LCM, okay? Sorry. I want to multiply 2/3 by a number that will make the denominator be 15. But I have to put the same number in the numerator and denominator. So I'm going to multiply by 5/5, because I'm only allowed to multiply a fraction by 1, and 5/5 reduces down to 1. Okay, so we'll do that. Let's see what that equals. Multiply across the top and across the bottom, we get 10/15. Now let's do the same thing for 1/5. Okay, take 1/5. This time I'm going to multiply by 3/3, because that will make the denominator 15, and 3/3 is a fraction that reduces to 1. So that's 3/15. So when I'm adding these now, the good news is, when I'm adding these now, the good news is that I have common denominators, okay? So we're going to go down here. Okay, so now we're just going to add 10/15 and 3/15. So I'm going to go down here, put 10/15 plus 3/15. I have a common denominator, so that's equal to 10 plus 3/15. Well, 10 plus 3 is 13. So I end up with 13/15. 13 is a prime number, which means its only factors are 1 and itself. 15 is not prime. Its factors are 1 and 15 and 3 and 5. There are no common factors, so this is a fully reduced fraction, and we're done. Now the back page goes faster than the front page, because numbers 6 and 7 are merely identification problems. Okay? So first we're asked to identify the slope of this equation, y equals 5, 6x minus 9. The slope is always the number sitting to the left of the x. So it's 5/6. That's, you either got it or you didn't get it. Slope equals 5/6. I'll just add in here that means we have a rise of 5 and a run of 6. Up 5, right 6. Okay? Number 7, identify the y-intercept of y equals negative 4x minus 8. The answer is negative 8, not 8, negative 8. So the y-int is equal to negative 8. Okay, and I'll just point this out. That means that the coordinates of the y-intercept are, open parentheses, 0, negative 8. And let's just remember that coordinates are written x, y. So my y-intercept is the y value of on the y-axis is 0, negative 8. Okay? All right, so here comes the graphing problems. My first equation, y equals negative 2/3 x plus 2. So it's very helpful, it's very helpful to make a note here. Slope and y-int. My slope is going to be negative 2/3. My y-int is located at 0, positive 2. So what I do is I go to 2, 1, 2 on the y-axis, and I'm going to put a dot there. I'll go ahead and fill this out. Okay, now from there, guys, the slope is telling me to go down 2, right 3. Okay, because that's the rise over the run. So what I mean is go down 2 from the y-intercept. We'll go down 1, down 2, over 1, 2, 3. So my second point is right here. And here comes the straight edge. Straight edge is so important. We're going to put the line in just like this. And make sure you put those arrowheads. Make sure the line goes all the way across the graph. That indicates that it goes on forever in both directions, okay? Now we'll do number 9. Y equals 5x minus 2. Now here, my slope is 5, but that means we're going to interpret it as 5 over 1, okay? In other words, up 5, right 1. My y-intercept is negative 2, which means it's located at 0, negative 2. Okay, so we're going to start at negative 2 on the y-axis. So negative 1, negative 2, right here. From there, we're going to go up 5 spaces, up 1, up 2, up 3, up 4, up 5, over 1 to the right. There's our dot. So this is going to be an upward sloping line, really upward sloping, 80 degrees. So we're going to go put this line in here. Put your arrowheads on top of it. And that's it. Okay, and finally, number 10, simplify, and then we're given a linear expression in 2 variables. So let's zoom in on this real quick here. The very first step is to distribute. We're going to distribute this 4 to both terms inside the parentheses. So here's what that next step will look like. 4 times x plus 4 times negative 2y plus 9x plus negative 3y. The distributive property, as a reminder, is A, open parentheses, B plus C equals A times B plus A times C. So just a reminder on the distributive property. Okay, so now we're going to simplify. 4 times x is just 4x. 4 times negative 2y is negative 8y. 9x is 9x. Negative 3y is negative 3y. Okay, and we can still keep these all separated like this with plus signs. You want to think of it that way. Now we're going to combine like terms. Okay. So I can combine 4x and 9x, and I can combine negative 8y and negative 3y. Okay, so what we'll do is we'll combine these together. We have 4x plus 9x. And then I can combine these two together. I have negative 8y minus 3y. And these are like this. And they're added together. Finally, 4x plus 9x is 13x. Negative 8y minus 3y is minus 11y. Okay, so this is your final answer, 13x minus 11y. There it is. Okay. Thank you so much for watching this solutions video for Test 1 Review version 2.